Solve the system of simultaneous equations, and in this case we're going to use substitution. There is another video solving this exact problem with matrix row reduction and another one using elimination, but here we'll use substitution. So to do substitution, we first of all need to rewrite one of these equations as y or x equals, and I'm going to take this one here, I'm going to make it x equals 3 minus 3y plus 2z. And when I have that, I'm going to substitute it into one of the other equations. So I'm going to take this one and I'm going to substitute it into the second one. So if I call these equations 1, 2, and 3, I'm going to sub into equation 2. When I do that, I get two lots of x, and x in this case is going to be 3 minus 3y plus 2z minus 4y plus 3z equals 5. Simplifying this, I get 6 minus 6y plus 4z minus 4y plus 3z equals 5, which is going to be minus 10y plus 7z is equal to negative 1. Now, to do the substitution, I need to continue substituting. So I want this in some form that I can then substitute into another one. So I'm going to, well, actually there's a few ways. I could rewrite this one. Let's look at what that will look like first. If I rewrite this one, maybe as y equals, I'm going to get y equals minus 7z minus 1 over minus 10, or possibly slightly nicer simplifying that to 7z plus 1 over 10. Now I've got a fraction here, usable, but makes it a little bit more tricky. Let's carry on, and I'm going to substitute that now into the equation I haven't used, which is into 3. So 3 is 4 lots of x, where x is this thing. 3 minus 3, but y is now 7z plus 1 over 10 plus 2z, and then plus y, but y is 7z plus 1 over 10, and then minus z equals 6. And now this has gotten quite messy because of these fractions. Now it will all fall out. Easiest thing to do is probably just to multiply everything through by 10 to get rid of that fraction. There was a slightly different approach here. Rather than doing this, we could have taken 3 and rewritten 3 as y equals and then substituted it into here. That would also have worked. But let's carry on with this, and then maybe we can have a look at that other approach in a minute. So expanding this, we're going to get 12 minus 12 lots of, I'm just going to leave this as this for now, plus 8x, oh sorry, 8z, plus, and again we'll leave this as this for now, 7z plus 1 over 10 minus z equals 6. Now, as I said, the easiest way to deal with this is probably multiply through by 10 to get rid of these fractions. So that's going to give me 120 minus 12 lots of 7z plus 1 plus 80z plus 7z plus 1 minus 10z equals 60. Multiplying everything by 10. 120 minus 12 times 7 is going to be 84z minus 12 plus 80z plus 7z plus 1 minus 10z equals 60. This is just a linear equation in z that we need to solve. So combining all these z's, we have minus 84z plus 80z plus 7z and then minus 10z. So that gives us a total of minus 7z. And then we have 120 minus 12 plus 1 is equal to 109. And I'm going to take that away from the 60. So 60 take away 109 will give me minus 49. That gives me z is equal to 7. Now I know z, I substitute that into the formula for y, which is 7 times 7 plus 1 over 10. That's that green rule, which is 49. 50 over 10 is 5. And then for x, I substitute in to that one I had right at the top, which I also have in blue here so I can see it. That's 3 minus 3y's, which we now know is 5, plus 2z's, which we now know is 7. So that's 3 minus 15 plus 14. That's going to be equal to 2. So we get x is equal to 2, y is equal to 5, and z is equal to 7, which is the same answer we got through elimination and through matrix row reduction. Now, here we see this complication with substitution. Sometimes we can get more complicated things appearing. Let's have a quick look at what I was suggesting might have been a slightly better way to approach this one. So another way we could have done this, the first step would have been the same. But then we could have gone, let's rewrite this one as y equals 6 minus 4x plus z. But x is equal to what we have up here. So 3 minus 3y plus 2z, and then plus the z. This could be simplified down to y equals 6 minus 12 plus 12y minus 8z plus z, which is minus 11y equals minus 6 plus 7z. So y is equal to minus 6 plus 7z over minus 11. And we could have done that and then substituted that one into here to get an equation just in z that we could have solved. Now, we still have at that point a fraction, but we're only having to substitute it in once because we've already dealt with one of the substitutions here. Doesn't particularly matter. You're going to have to rewrite two of the equations in the form x, y, or z equals, and then substitute it into the other equations in some way. Here the first route we use 1, subbing it into 2 to get this one, and then subbed into 3. Here we used 1, then subbed it into 2 to get this one, and then used 3, a rearranged version of 3 to sub into 2. So we've used all three equations in both cases. It doesn't particularly matter which way you go. Likelihood is, though, you're going to end up with some fractions you have to deal with in this approach.